previous year's questions of GATE and IIT-JAM. In the previous video, that is part 8, I have discussed CSIR-NET questions. So here it will be GATE and IIT-JAM related. So before starting, I would like to mention that please check the videos that are related to Carbene, and the Carbene playlist link I have given in the description box. Okay, so let's start. First question. The major product formed in the following reaction. Now when we are seeing this type of reagent, CH2I2 and zinc copper couple, it is obviously Simon-Smith reaction, which involves zinc carbenoid. Fine. So carbenoid is basically carbene-like species. So it actually gives the same result that you can expect from carbene. So details I have already discussed in the previous videos that are carbene related videos. I am not going into the details. So this is Simon-Smith reaction, that is fine. Now in Simon-Smith reaction, here if you look at the that is geometry of this CC double bond, it is basically Cs. Now Cs and trans, these two are always maintained. So in the product there will be obviously Cs structure, not trans. So on the basis of that, you can cancel this one, option B, because these two are trans to each other, that is this bond and this bond. And this one also trans to each other, so B and D you can cancel. Now among A and C, just by applying common sense, obviously you will choose option A, because here SiMe2PH, this large group is above the plane. So what we will understand that obviously this CH2 insertion, that will be below the plane, and accordingly option A will be the correct option, and that is actually true. But though we have reached the correct option, the explanation that we are giving, it is not at all correct. So for this question it is fine, but maybe for other question, if you apply the same logic, you will not reach the correct answer. Okay, so that is why we have to know here the actual explanation. Now that is based on House model, which you can find in Clayden. Page number also I am giving 895. So if you consider this model, then what happens? First of all, you have to consider these three groups, that is methyl as medium, hydrogen as small group, and this large group as L. So if I draw it in the similar way, so above the plane this is large group, this is small, and this is medium. So I am not writing the groups, I am writing S, L and M. Now what will happen? You have to arrange these three groups in such a way so that the small group, it comes in eclipsed position with the CC double bond. And under this condition, what will happen? This is basically 60-degree rotation. So this will be the position of L and M. Now M will be below the plane, L will remain same. You can do this rotation yourself. Now epoxidation can take, sorry, not epoxidation, here it is cyclopropionation, that is CH2 insertion. So above the plane or below the plane? Now below the plane we have this medium group, and here we have this large group. So that is why this will not be considered, this will be considered, and accordingly we are reaching the same conclusion, that is option A should be the correct option, below the plane addition. And this is also true if we have suppose you don't have this reagent and you have reagent MCPBA, then also the same explanation you can apply. This is basically diastereoselective epoxidation, but also applicable for cyclopropionation. Diastereoselective, why? Because we already have chiral center, and the new that is the cyclopropane ring or epoxidation, that may be below the plane or above the plane. Okay, so then we can apply this model. So option A is the correct option. Here in presence of this azide type of reagent that is given, this is number 1, then we have this rhodium complex. So first this CH2, which is basically active methylene, at that position there will be generation of diazo compound. So NH, C double bond O, and now here I will write N2. Now this is basically the point where the carbene will be generated. Okay, so instead of writing N2, that is in presence of rhodium complex, there will be this type of carbene generation. Now in the medium, in the molecule, this lone pair over nitrogen, that will act as nucleophile, and it will attack this electron deficient carbene. So as a result, now we are getting nitrogen is positively charged because it has attacked. There is a newly generated bond. So 5-membered ring we are getting. So it has attacked here, and at that position we also have CO2, sorry, let me draw it clearly, probably I have added one extra carbon. 1, 2, 3, 4, 5. So 1,5 bond will be formed. So this is 1,5 bond, and then we have with this carbon CO2 BN group. So here there will be generation of negative charge, and here we have NH positive. So this proton now it will go towards this negative, and as a result finally we are reaching this neutral compound, 4-membered ring and 5-membered ring. So it is matching with which option? It is matching with option 1. Okay, so this will be the correct option. Next question, formation of the ketone 2. So product is already given, starting material also given, which is diazo compound. Now in presence of this silver salt of benzoic acid, there will be silver carbenoid type of species will be generated. Okay, so formation of the ketone 2 starting from the diazo ketone, because it is diazo group and ketone both are present, it will involve which of this process? So A and B is saying it is generation of carbene, C and D it is saying generation of ketene. So let's see first what will be generated. As here the silver salt is given, I am ignoring the stereochemistry because that is not required here. Here we have the cyclopropane ring, and here we have methyl group. Now the position where this C double bond N2 is present, that will be the position where this carbene will be present. Now once you have this type of carbene, and there will be wool-free arrangement. So because of this wool-free arrangement, now this CC bond it will attack here, so this CC bond will be broken. So 5-membered ring as it is, cyclopropane ring that is also not disturbed. We have these groups as it is, and now with this carbon there will be CH double bond C, then double bond O. So it is undergoing through ketene. Now see, there is generation of carbene as well as there is generation of ketene. So now we are not able to understand which option we should choose. But next thing, it will be 3,3 sigmatopic rearrangement, on the basis of which you can understand that it is actually option D. So what will happen here? Let's do the numbering. 3, 2, 1, and here also it is 3, 2, 1. So this 3 it will attack here. 2, 3 double bond will be broken. Between 1 and 2 there is a newly generated bond, and 1, 1 sigma bond is broken. So now what we are getting? Cyclopropane ring as it is. There is methyl. I am again ignoring the stereochemistry. So now there will be 7-membered ring, because 1, 2, 3, 1, 2, 3. 3, 3 now connected. But 1, 1 bond broken, and between 1, 1 there is insertion of this carbon. So that is why it will be 7-membered ring. So if I follow the original numbering, it will be 1, 2, 3, then again 3, then we have 2, and then in between 2, 1 there is 1 carbon. So it will be like this. So 1, 2, 3, 4, 5, 6, 7. So there are total 7. Now between 1 and 2 position there is CC double bond, and between these two 1, that is these two 1 and 2, there is double bond. So now it is matching with the structure that is given in the question, right? So it is obviously it is also involving carbene, but we have to choose this 3,3 sigmatopic rearrangement. So that is why it is option D, that is generation of ketene, because ketene is also generated. First there is generation of carbene, then ketene. So option D is the correct option. The product of the following reaction, how many, that is 13 carbon spectrum, how many peaks are there, that is also given. Total 6 line. But if you observe this 175, obviously you can eliminate these two structures, because they are carbonyl carbon, whether that is, it is actually ester. These two are ester, but here we do not have any ester carbonyl. But this peak, it is suggesting that you can eliminate A and B. Though even the 13 carbon spectrum, suppose that is also not given, then also we can solve this problem if we understand the mechanism properly. So here First, in presence of this cis double bond N2, that is this carbon, there will be generation of carbene like this. And this CC bond, now it will be shifted here. We will get a 5-membered ring like this, double bond C. So ketene will be generated. So if I am numbering here 1, 2, 3. Now this is 1, this is 3, and this is 2. So here basically 1, 2 bond broken and 1, 3 bond formed. Now in presence of MEOH, it will attack here and there will be formation of CO2M, and this CC bond will no longer be present. So it is matching with this one, that is option C. If you really want to know that which peaks will be having all this, so obviously this is 175, so this is more or less same as the data it is given in the question. And then we have total 52, 50, 46, 37, 33, total 5. So these two are same. So suppose it is type A, this is type B, then we have type C, type D, and this is ester carbonyl, and then we have E. So total 5 types of carbon. So option C, that is the correct option. Here we have ketone, and we also have this secondary amine. Look at the reagents. PTSA, paratoluene sulfonic acid, solvent, heat. Then the second reagent, that is actually, it will generate carbene. But before that, whenever you have this type of reagent and ketone and secondary amine, it is basically formation of enamine. And if you want to know details about enamine, then I have also made a video regarding that. You can watch that. For that, click on the link appearing on the screen. So this type of enamine, that is combination of CC double bond and amine, both present in the same molecule, that is known as enamine. So this product you will get after the application of the first reagent. Now this reagent combination, it will generate CCl2, and we have CC double bond. So what will happen here? 3-membered ring will be formed. Cl, Cl. Okay. Next, this lone pair, if it is making CN double bond, now let me do numbering. 1, 2, 3, 4, 5, 6. So here 1, 5 bond will be broken. At 6 and 5 there will be generation of a new bond and 1 Cl will be removed. So finally, now N is positively charged because it is, now there is a double bond, and we will have a 6-membered ring. So always do numbering, otherwise there is a chance of mistake. So now it is 1, 2, 3, 4, 5, and 1, 5 bond broken. At 6 and 5 there is a newly generated bond, and at 6 there is already a clone. And finally, when you are applying H3O+, that is acidic condition hydrolysis, so at this position there will be C double bond O. So it is matching with option D, last molecule. Fine. Now this is MCQ type of question, that means more than one option may be correct. This type of question we get in JAM. The products P and Q, and also there are some minor products, but we just have to focus on P and Q. Here the carbene that is given, it is already mentioned that it is singlet. Now when it is singlet state and you have this type of trans configuration for this alkene, obviously from trans you will get trans, from cis you will get cis. So there is some specificity, stereo specific, right? So you will never get, from trans you will never get mixture of T and C, or from cis you will never get mixture of T and C. So it is always trans if it starting material is trans. Now just based on this information, see, look at the options. Here this is trans, this is cis, option B trans, trans, option C cis, trans, cis, trans. So just on the basis of this, because this is mixture, it is only option B where you are getting both this P and Q as trans. So this must be maintained. So though it is MSQ, but basically only option B will be correct. So don't make the solution so complicated just by considering the stereochemistry of this carbon also, because that is not required. Just on the basis of this information, because it is singlet state, we can reach the correct option, which is option B. So this is basically dimer-dimer reaction, type of reaction for pyrrole. Potassium salt of pyrrole is given. Reagent CHCl-ETO-N. Now you will see that dimer-dimer there is mostly KOH or NaOH mentioned. So when it is KOH and NaOH, basically we get two types of products. These two are the products, but this product, that is 3-chloropyridine, that will be major if you take sodium ethoxide type of base. But though that is not required, because the other possibility that is not mentioned in any of the options. All the options there is 6-member, so we don't have to bother about that. I am just saying it for information. So as it is 6-member ring and pyridine ring will be there. So see, in presence of this CCl2 carbene, there will be formation of this type of, that is one of the CC double bond, there will be generation of this 3-member ring. Now once this 3-member ring is formed, now if I do numbering 1, 2, 3, 4, 5, 6. Okay, so now what will happen, because of this donation of lone pair, here 4-6 bond will be broken, and at 4 and 5 position there will be generation of a bond, and this Cl will be removed. So finally what you are getting? You are getting 6-member ring. This is 1, 2, 3, 4, and 4 and 5 position there is a bond. Here also between 1 and 6 there will be a bond. 4-6 bond broken, and at 5 position 1 chlorine removed, 1 chlorine will be there. So we are reaching the correct option, which is option C, 3-chloropyridine. Now this is also as you can see from the question style, statement or statements, carbene is or are. That means more than one option may be correct. First statement is saying carbene is a neutral species. Now this is true, because carbene, there are 2 bonds and 2 non-bonding electrons. Now if you consider carbocation, it is like this, carbene like this. So it is just basically how we calculate formal charge. If you follow the same procedure, you will reach this type of charge for carbocation and carbene. But that is actually not true for carbene. That is, there is no charge. So it is neutral species, though it is that is nucleophile can attack here, because it is, there is some deficiency, octet is not complete, but it is neutral. It is not, there is not any charge. So it is correct statement. Carbene is neutral species, it is correct statement. Then second statement is saying carbene is intermediate in Cartesian rearrangement. Now this is Cartesian rearrangement, where starting material is this type of acyl N3 compound, and there is generation of nitrine, it is not carbene, and then there is CSIR-NET and further reactions are there. But important point is, it is not involving carbene intermediate. So this is not correct, this is false. Carbene can insert into both sigma and pi. Now how it can be inserted to pi bonds? Several examples we have seen. CC double bond, you know, there is cyclopropanation, and when there is a CH insertion, that is in between C and H, carbene can be inserted. That means this statement is also true, it is possible. And the last statement, carbene is generated from amines on reaction with nitrous acid. So if you have amine in presence of nitrous acid HNO2, carbene is not generated. Here generation of Rn2 plus diazonium cation is generated, not carbene. So this is not correct. True, false. So these two will be correct, A and C. Here we have to write the structures of K2O. So first there is generation of carbene. So what will happen? I am writing here pH. So here we will have carbene in presence of TBUOK and TBUNI. Now once this is formed, carbene, basically here you have 2 hydrogen. So 1 H and 1 Cl will be removed. So that is why in presence of this type of strong base, carbene is generated. Next, this CC bond will be migrating here. Now if it is migrating, suppose this is 1, this is 2. Now with pH there will be 2 carbon. So this is 2, this is 1, and 2 carbon there is negative charge, here positive charge. And you can also write the same structure with a double bond. So this is actually L. This is L. In presence of MCPBA, beta-chloroperbenzoic acid, there will be epoxidation. Once there is epoxidation, next in presence of dilute HCl-MeOH, so this is basically M. After M formation, in presence of HCl, there is protonation because dilute HCl is there. Now depending on whether you are attacking MeOH from which side, depending on that we can get two different types of product. So if it is attacking from left hand side, you will be getting PHOMe. So suppose this is N. Another possibility is, now here we have which. So these are the two possibilities, N and O. Okay, so this is L, CC double bond, this is M, epoxide. Don't think in M there is positive charge, I have just jumped one step. And then in presence of dilute HCl-MeOH, epoxide ring will be broken, but with the possibility of two types of product. Fine. So that's all I have for you in this video. In the next video, maybe I'll come with some new problems, or it may be a new topic also. Okay. Thank you for watching.